Hello everyone, my name is Raresh Arvinte and I'm a PhD graduate in computer science and also a QA engineer for Bytex. Today I want to talk about something that is becoming extremely important in every industry, how we actually build AI systems that work in the real world. Many people think AI success depends mainly on advanced algorithms or powerful models. However, in reality, most AI projects fail for much simple reasons. The biggest problems are usually poor data quality, like using images with apples to identify oranges in an image. Unclear business goals, like trying to solve multiple problems with the same resources. Weak system design, like monolithic implementations versus modular ones. And privacy or compliance issues, like using sensible data without any approval to use it. So today, instead of focusing only on models, we look at the full pipeline behind successful AI systems, from raw data all the way to reliable business decision. So here's what we'll cover today. First, we'll understand why many AI projects fail. Then, we'll look at how raw data becomes intelligence inside AI systems. After that, we'll discuss what makes information useful in machine learning. We'll also talk about designing AI systems correctly, GDPR and responsible AI, and finally, how AI systems continuously improve over time. So, how we go from data to intelligence? To build effective AI systems, we need to understand the difference between data, information, knowledge, and intelligence. First, we have the data. This is raw, unprocessed material, like the application usage logs or heartbeat readings or Google Maps images. By itself, data has almost no meaning. The next level is information. This data that has been cleaned, structured, and labeled. For example, labeling images. Hey, this is an image with an apple. This is an image with a red car. Or extracted features like red flower, blue flower, emotions like happiness or sadness. This is actually where most AI engineering effort happens. Then we move to the knowledge layer. This is what the model learns from the information. Like patterns, a flower can be red or yellow or blue. And finally, we reach the intelligence. This is where the system uses knowledge to make predictions or recommend actions or, I don't know, generate alerts. And this is the key point. AI only becomes valuable when it supports real decision in production systems. Okay, now let's talk about information in machine learning. How this information is useful for it. One important concept is entropy. Entropy measures how uncertain the data or outcome is. If entropy is very high, it means the model is mostly guessing. The goal of machine learning is really just to reduce the entropy. Next, we have the information gain. This measures how much a feature helps to reduce the entropy. So, if we have good features, we simplify the model and improve predictions, like the color of the fruit helps us identify the fruit. Also, we can have bad features that only add complexity without improving results. Let's say the emails. These emails are unique and doesn't give us any informations about the prediction. Another important idea is the signal versus noise. Most datasets contains a lot of useless or chaotic informations. Let's say we want to buy a house and we have some information about the house, like the house size or the number of bedrooms or the distance to the supermarket from the house or useless informations like the owner's favorite color or how is the weather today. You can already see where I'm going. The signals are useful informations like the house size, which can help us to decide if we are buying this house or not. By the size, it will increase also the price. And the noise are informations like the owner's favorite color, which doesn't add any information that help us in deciding the outcome. Basically, it's noisy, useless. One of the biggest engineering challenge is separating meaningful matter from irrelevant noise. But we also have to think about the feature's relevance. Sometimes a feature looks like statistically important during training, but completely fails in production because of drift or leakage. An example is the income. Looks useful, right? To know the income of a person. But in productions, the bank does not know the future income, how it will look. So it cannot predict in the future his mathematics calculations or to uh, tell a person how it will move forward. But it can also be hidden by laws or it cannot be accessible. So it's become noisy in the end. So in the finally, we have the label quality. If the labels are wrong, the model learns the wrong behavior. Let's take as an example a spam filter. Suppose that many legitimate emails are accidentally labeled as spam, like school messages, work emails, and then the model will learn from this. Hey, emails containing these patterns are spam. In production, it will start to incorrectly hide important emails. In many real projects, improving label quality has a bigger impact than changing the algorithm itself. Okay, now let's move forward and reiterate the steps. The first step is to start with a goal. One of the biggest mistakes in AI projects is starting with technology instead of starting with a business goal. Before building anything, teams should define five things clearly. First, what exact problem are we solving? Without a clear decision, teams optimize metrics that don't matter. Second, how do we measure success? Accuracy should be measurable in terms of business impact. For example, faster support or lower operational cost. Third, what information is actually required to make the decision? This is important because collecting unnecessary data increase complexity and compliance risk. Fourth, what are the constraints? Legal, ethical, technological, and finally, what are the non-goals? In other words, what should the system not do? This helps keep the project focused and prevent accidental misuse. A good AI always starts with a clear business objective, not with hype. Next step is how we collect the data. AI systems collect information from many different sources. One common source is internal company systems, like production logs or user events. These usually provide a high-quality signal. Another source is user-provided data, like chat messages or image ratings or video ratings. This data is often directly connected to user intent, but it also introduces privacy and bias concern. We also have the sensor or device data like GPS images or coordinates, cameras or microphone images or signals. This enable real-world automation, but create major regulatory and storage challenge. Many companies are also use third-party APIs or web data. These are fast and cheap to access, but often create legal risks and quality problems. The important lesson is more data does not automatically create better AI. Now that we collected the data, it's it's time to see how we transform it in useful information. This stage is probably the most important part of the entire pipeline. Raw data must be transformed into reliable information before models can learn from it. The first step is labeling and annotation. So here we have, for example, tagging the text or classify images. Next, we have to label the labels that give data meaning. Like, I don't know, we clean or normalize the data. This include removing duplicates or handling missing values. After that, the data is structured and organized using consistent schemas and categories. Then, engineers extract features or generate embeddings. This helps the model understand patterns more effectively. Finally, the information must be validated with accuracy metrics and or coverage gaps. And this is extremely important. Most AI engineering work happens here, in this step, not during model training. Okay, now let's talk a little about the GDPR and the responsible AI. Today, AI systems must also comply with regulations like GDPR. GDPR introduced several key principles. The first is transparency. User must understand what data is collected, why is collected, and how it is used. Second is the purpose limitation. Data collected for one purpose cannot silently be reused for another model. Third is data minimization. Companies should only collect information that is actually necessary. Then we have accuracy, storage limitation, and security in how we can do this. In practice, that means we have to also cover encryption or access control. And finally, we have the user rights. So your user have the rights to access, correct, or delete their data. So responsible AI is not just a legal requirement anymore. It directly shapes how AI systems are designated and deployed. Okay, now let's see how information is used in our AI systems. Once the pipeline is working, AI systems use information in many ways, like detecting the fraud, recommend products, or automate workflows. Some systems work in real time, while others run in batch processing workflows. But there is one very important rule. The quality of the decision always depends on the quality of the information. Modern AI systems also improve continuously through the feedback loop. User interactions, performance metrics, and detected errors are fed back into the system. This helps teams to detect model drifts or correct mistakes. This is another important point that every company needs for fully automation. Sometimes AI-generated insight and analytics already create enormous business value without deploying highly complex autonomous systems. To conclude, successful AI systems are not built only with good models. They depend on high-quality information or a clean business goals, a reliable pipeline, a strong compliance, and a continuous improvement. The companies that succeed with AI are usually the ones that treat AI as a complete engineering and information system, not just as a model that is used. Thank you very much.